All right, our first video for CAM profiles will be the knife edge follower. And what we're going to do is use the displacement diagram in example 1 to build the CAM profile, or basically design the CAM geometry that would satisfy the constraints based on this problem. So these are the directions that we're going to be following, and I'll explain it as we go along in SolidWorks, but a couple things to note. The base circle is based on the design of the CAM and the constraints of whatever we're designing that CAM for, whether it be size constraints, airflow constraints, so on, so forth. We'll consider it to be spatial constraints in this application. We're going to draw the follower in home position because the problems we are looking at are in line. They're all going to start at 90 degrees. And I'll explain to you what radial lines are, but what we're going to do is draw lines from the center of the CAM to the outside of the base circle. And for each displacement at each angle, we're going to add that displacement to that line. Now, something to note, based on the rotation, if the CAM is rotating clockwise, then we draw our displacements in the counterclockwise direction. Because if the CAM is moving clockwise with respect to the follower is moving counterclockwise with respect to the CAM. Once we do this, we're going to connect those displacements with a smooth curve, and that will deem our CAM profile. Pretty easy to do with a knife edge follower, especially when it's in line. So let's get to it. So following along, if you look at example 1, this is what we're working through. And you can see here that we could look at this in terms of time or in terms of configuration, our different angles. Remember, we've worked with this before. When we're building our CAM profile, if you remember, we talked about when would we use this to understand the motion, displacement. We would use the angle to actually build the CAM itself. So this is the second application that we began to discuss with CAM displacement. Here are your requirements. Your CAM has to have a base circle of 90 millimeters and has to rotate clockwise. So we're going to build our follower motion counterclockwise with respect to that CAM. This is the displacement in millimeters of our follower at each of these locations. So this is the table you should have in front of you. I'll be referring back to it, but I won't open up to it every time. So example 1, slide 13 is the first example we are working with in SolidWorks. All right, so let's get to it. So I'm already set in millimeters here. We're going to go ahead and sketch on the front plane. And what we're going to start with is just drawing a base circle of diameter 90 millimeters. So we'll go ahead and smart dimension this guy to be 90 millimeters in diameter. All right, now we want to draw that CAM follower at the home position. One thing I think that will make this a little bit of an easier process is let's give ourselves a Cartesian coordinate system just so we can see what we're working with here. So we'll go ahead and do that. And then I'm just going to make these construction lines. I think I can grab both of these. And nope, I don't want to do that. Actually, I can make these for construction, but I do want to make these infinite length as well. And now we have X and Y axes just for reference here. So our CAM follower, it's a knife edge follower, so it's just going to look like, well, bet you can guess it, a knife edge. Oops. All right. Okay. And I'm just going to go ahead and mirror these guys. And then I'm going to mirror it about the y-axis just to make a nice little follower here. And I'm okay with the fact that it is not constrained. We can add dimensions later. So now notice this is our base circle. And what we'll be working with is building the CAM profile. So if you notice, our increments, for example, 1 are 0, 30, 60, 90, so on and so forth. So we want to build radial lines that are 30 degrees apart. Now, I'm going to grab the center line, and I'm going to be using more constraints here to make life a little easier. and going ahead and making sure for that first line that we dimension this properly, and that this should be 30 degrees from that 90-degree axis, exactly 30 degrees. And now to make life a little easier, what I can do from here is just go ahead and use the sketch pattern to create a circular sketch pattern. I'm going to grab this guy, and we need 360 divided by 30, which is 12 increments. I'm just going to go ahead and say 12 here over 360 degrees and build in those lines. So these are all the different locations that our CAM profile will be splined from as we build that profile. So these are our radial lines in our base circle. Now what we're going to need to do is add the corresponding displacement. Now notice right here, this is 90 degrees. This is where we're starting. This is where our follower starts. Thankfully, we only have to draw one follower. But what we are going to do now is move 30 degrees. And as we do this, we're going to go ahead and add the displacement at 30 degrees. If you notice, the displacement at the cam at 30 degrees, or excuse me, of the cam follower at 30 degrees is 0. So now we can move on to that 60-degree mark. And the displacement there is 3 millimeters. So we can go ahead and add lines. So we want to add from that original radial line, and if we get lucky, we can catch that line and continue to keep it collinear. I noticed some of my lines would do that, some would not, and if not, we can always add a relation. But these two lines should already be collinear, and if they're not, we will make sure that they are. And now we want to dimension that line. And we're going to go ahead and dimension that line, to be 3 millimeters in displacement. Okay, now we're going to go over to the 90-degree mark, and we're going to do this process all over again. We're going to add another line here, and this one should definitely be collinear to this x-axis line right here, and let's go ahead and dimension it. And if we look at the table, it tells us that the displacement for this line is 9 millimeters at 90 degrees. Note I'm taking that information right from this table. Here's 9 millimeters at 90 degrees. And it's always 90 degrees from that home position. All right, back to SolidWorks. So we can see here, I'm just going to scan it a little bit here, get a better perspective. Let's go ahead and build another line. And I'm not looking for any constraints there. And I'm just going to make sure I add these relations. So when we build the spline, we don't have any troubles making sure that these two lines are collinear. And we'll dimension this. And we're going to do this process all the way through 360. In fact, we can stop at 330 since 360 brings us back to the home position. All right, now notice we're at 30, 60, 90, 120 degrees, which is a displacement of 15 millimeters. All right, now we can do the same thing here. And you're going to see this process is pretty simple right now, which is just fine for me. It's fine for you. So let's go ahead and, go ahead and add the relationship. These lines are collinear. Okay, and then displacement would be, now we are at 150, and at 150 degrees, that displacement should be 18 millimeters. And now we've got another line right here. And that displacement, if we smart dimension this, if I'm correct, notice this is 180 degrees from home position. So this should also be 18 millimeters. And now if we take a look at 210 degrees, that should be a displacement of 15 millimeters. So I'm just going to go ahead and add that. Verify collinearity here. You can see this is more of a redundant process than it is a difficult process, and it's only going to get easier from here. Oops, I say that, now I can't get my dimension to be nice. There we go. So now we are at 210 degrees, so we'll go back to 15. You can notice there's some symmetry in this displacement. Build another line over here. I'm just going to go ahead and add relations to make these collinear. The process for doing or building a cam profile for the spherical follower isn't much different, except we have a few added constraints because we have to think about the center of the sphere as well as the edge of that spherical roller follower. All right, so we're at 210, 240. That's going to be 9 millimeters in displacement. You can probably see the symmetry here. And then it looks like we have one more to add, and at 270 degrees, we should expect to see a displacement, or we are building and designing our cam to have a displacement of 3 millimeters at this location. Now notice at, right now we're at 90, 180, 270, at 300, 330, and 360, we have 0 displacement. And now we are pretty much almost ready to completely design our cam profile. So because our cam is curved, we're going to use the spline feature. And what we're going to do is we're going to start at this home position, and we want to draw a spline that catches all of these points at the location of the displacements that we just created. Really have to love this spline feature because it is very efficient to make this process as easy as possible. There's our spline. Awesome. So guess what, guys? That's it. So I'm just going to exit the sketch so we can get a better perspective of it. We've just built our first cam that will give us the prescribed displacement that's needed for this application. Pretty nice, right? Not a very difficult process, which is always a great thing. So here, this line right here, or shall I say this curve, this would be the geometry of your cam. And this is what we would want to machine in order to have this follower move or displace up and down appropriately as this cam was moving clockwise. All right, I hope that this was helpful, and let me know if you guys have any questions with the video. And that's it. There'll be a second video for your inline spherical roller follower that will help you with the next lab problem.